Bismillahirrahmanirrahim. In this session, we will discuss section 4.2 electrical quantities. It's third video in this for this topic, and in this session, we will discuss some now put this into practice questions that is available on the page 203 of this book, Tom Decken and Heather Kennett, to 2021, published by Hoddles Education. So let's start this question. A lamp has a resistance of 12 ohms and a current of 1 ampere passing through it. Calculate the potential difference across the lamp. So we have given this resistance and current, and we have to find this potential difference. So V is equal to IR, and ampere is 1 ampere, and this is 12 ohms. So 1 ampere and 12 ohms. So 12 multiplied by 1 is 12 volt. And calculate the power of the lamp. Power is equal to VI. So voltage is 12 volt, and this I is 1 ampere. So this is 12 volt. Now, how much energy is transferred to the lamp in 10 seconds? So we have to multiply this power with time, that is 10 seconds. So we will have this 12 watt into 10 seconds is 120 joules. So this time for 10 seconds. So this is part 1, question number 1. Now question number 2, how much electric motor attached, how a small electric motor attached to a 12 volt supply has a current of 0.3 ampere. A motor with a 12 volt supply getting 0.3 ampere passing through it. Calculate the power of the motor in watts. So this is voltage and current. So power is equal to VI. 12 volt into 0.3 ampere is equal to 3.6 watt. Give the power of the motor in joules per second. So this is watt is basically joules per second. How much energy is transferred to the motor in 1 minute? So energy is transferred in 1 minute. So 1 minute is basically 60 seconds. So we will multiply this 3.6 joules per second with this 60 seconds, and we will have this 21.6 joules. So this much energy will be transferred. Paying for electricity supply companies charge for the amount of energy they supply. A joules is a very small amount of energy, and a larger unit, that is kilowatt hour. So our homes, every unit is basically a kilowatt hour. So if we use 1 kilowatt hour in our home, it means 1 unit has been consumed. So that 1 kilowatt hour energy is used by 1 kilowatt appliance in 1 hour. So this 1 kilowatt hour is defined as 1 kilowatt appliance is operated for 1 hour, then we actually consume 1 unit or 1 kilowatt hour. So 1 kilowatt hour is kilowatt, kilo means 1000, and watt is joules per second, and this hour is basically 3600 seconds. So we'll multiply this, and we have this much 3.6 megajoules. This is joules. This second will cancel with this second, and on multiplying this, we have this 3.6 megajoules. 1 kilowatt hour is 3.6 megajoules. Now put this into practice. If a price of 1 kilowatt or 1 unit of electricity is 10 cents, how much will it cost to use a 6.4 kilowatt oven for 2 hours? So we have the price is 10 cents for 1 kilowatt or 1 unit of electricity. So this is 6.4 kilowatt, and we have used this for two hours. So 6.4 kilowatt into 2 hours is equal to 12.8 kilowatt hours. So this is 12.8 kilowatt hour means 12.8 units. So we'll multiply this per unit. So this is kilowatt, and this is 10 cents. So multiply with this, and we have this 128 cents per kilowatt hour. So this is per kilowatt hour, 10 cents per kilowatt hour. So we have this 128 cents. So 128 cents is basically divided by 100. So we will have 1.28. So $1.28 is the cost for operating this oven for 2 hours. So if the cost of 1 kilowatt hour of electricity is 10 cent, how much will it cost to use a 150 watt refrigerator for 12 hours? The unit price is 10 cent per kilowatt hour. So cost of 1 kilowatt hour is 10 cent is given, and we are using energy of 150 watt into 12 hours for 12 hours. So we multiply this 150 watt with 12 hours. So 150 multiplied by 12, this is 1800 watt hour. So divide by 100 to make it kilowatt. So this is 1.8 kilowatt hour. So for 12 hours, 150 watt refrigerator for 12 hours will consume 1.8 unit. So the price of 1 unit is 10 cent. So we will multiply it, so we'll have this 18 cent. So if 150 watt refrigerator operate for 12 hours, it cost will be 18 cent if the unit price is 10 cent for 1 unit. Now test yourself on page 205 of this book. How much energy in joules is transferred to 100 watt lamp in 1 second? So 100 watt lamp for 1 second, this is multiplied by this watt is basically joules per second. So second will cancel and the joules will be the result. Similarly for this 5 seconds, we multiply this 5 seconds cancel, and this 5 multiplied by 100 is 500 joules. So 60 multiplied by this 6000 joules, 60, and this. So because this is 1 minute, so 1 minute is basically 60 seconds. So what is the power of the lamp rated at 12 volt and 2 ampere? How much joules of energy are transferred per second to a 6 volt 0.5 ampere lamps? So part A, we have 12 volt and current is 2 ampere. So the power is equal to VI, 12 volt into 2 ampere. Basically 2 multiplied by 12 is 24 watt. And how much joules of energy are transferred per second to a 6 volt 0.5 ampere lamp? So the energy per unit time is basically the power. So this is 6 volt and multiplied by 0.5 ampere. So this is 3 watt, which is 3 joules per second. So 3 joules energy will be transferred per second. So this is part B of this question.